Okay, this is possibly the most difficult aspect of transformations when not using tracing paper. With tracing paper, you can find another tutorial on this, it's much easier. Without tracing paper, things get a little bit tricky. So let's start by drawing a shape though. So here we have a normal average triangle. Let's say for the sake of today that it's an equilateral triangle, all the sides are the same length. When you come to rotating it in your exam, you will have a centre point for rotation, centre of rotation, which, let's say, for instance, it's here. Okay. You may be given a coordinate, which you'll have to plot, or if they use the word origin, just be aware that this is 0, 0. So right in this very centre of your axes, okay, that point there. When you come to read the question and you've plotted your centre of enlargement, you need to be highlighting. You need to highlight the direction you have to turn in. Please remember that clockwise, if you think of a clock, will turn your shape in this direction. Anti-clockwise goes in the opposite direction and the other way around. It doesn't make a difference when it's 180 degrees. Either way, if I was to turn this shape around 180 degrees, so it's upside down, that's what 180 degrees does, turns things upside down. Either way, anti-clockwise or clockwise, you end up in the same place. It makes a difference when it's, say, 90 degrees or 270. So here we are, here's my triangle. It has, I've drawn another one so it's changed slightly. After reading the question carefully, you need to think about how far you are turning it. Now if you think of a, almost like a compass, you've got 4 points, and this looks a lot like the grid you'll be drawing on. It's like your X and Y axes. North points straight up. If you turn at 90 degrees right the way around, you'll then point east. So should you turn 90 degrees clockwise, your shape will end up going from pointing upwards to pointing to the side east. If you have to turn 90 degrees anti-clockwise, you'll end up going from north to west, pointing in that direction. To begin practicing this, I would suggest using arrows is good, using triangles are good, just because then you can see them pointing in a specific direction. You can see how it changes. So once you're clued in with how far you're turning it, where you're turning it around, and which direction it should look in, try turning your page. Try turning this around so that you know what your shape should look like at the end. If you can get a good visual aid, you know that if you are doing it wrong, at the very end, you'll spot the differences and you might be able to correct it. Right, so the method is, it's a fairly simple method, but actually getting it precise, the precision of it is the problem. If you find your corners aren't quite on the grid lines, you must remember to neaten up and put them on the grid lines, otherwise you'll end up getting it wrong. So you must remember, if this is on a line, it's going to end up where two lines meet, where it crosses over. It'll end up again on an actual integer, on where two grid lines. So to do this, you measure, but the measuring involved, the distance from each corner to the point. So let's imagine that that is 1 centimetre. Then, if we were turning 90 degrees anti-clockwise, I would know that I'm turning in this direction. My arrow, or my line, is going to go from south, say this is pointing south, it's going to turn around, it's going to end up pointing east. So I have to measure my 90 degrees, so I know where I end up. And then I measure that distance again, just like you did with reflection. So you're measuring 1 centimetre, that will tell you where that side ends up. And you do the same for each of these corners. You draw a very straight line even if it's diagonal, it might not be vertical or horizontal, from each corner to the line. I'll do this in a different colour so you can see it. So imagine, here's the second one. Okay, there's my, should be a straight line. Please do yours with a ruler. You'll then again measure 90 degrees from this line. You'll measure the distance as well, so imagine that is 4 centimetres. You will draw a line that's the same length, going in a right angle again, 90 degrees, and where that ends up, that tells you where that other corner is. And then you'll do exactly the same with your final corner, drawing a straight line, measuring its length, measure the angle of rotation that you need, which is 90 degrees, and this will tell you where your third and final corner is. Then it's a case of joining these points together, and it will be the same size shape. The actual shape will not have changed. All you'll have done is turned it around, rotated it, but as well rotated it about this point. So just to recap, step number 1 is to measure, okay, from corner to the point being the rotation point. Number 2 is to use the line that you've drawn, this line here that you drew, to measure the angle of rotation. And then step number 3, once you know the direction you're going in, you then re-measure that distance from number 1, and where you end up is your final point. So re-measure to find new location of corner. This is the one that takes some practice. It's all about your accuracy of your measuring. It's all about measuring those angles properly as well. If you need some help with this, please do come along to a clinic. Otherwise I can show you how to do it with tracing paper, which is much easier. But just in case you don't, it's a good one to know. All right.